I'm Anil Kumar, and here is an extremely important topic for you, characteristics of polynomials, and we'll discuss about zeros, basically types of zeros. For the example, consider a polynomial of degree 5. Explain the different types of zeros this polynomial can have. Okay, so one by one, I will teach you and explain you what are the different possibilities and what type of zeros can we have, right? So let's begin with x to the power of 5, the polynomial x to the power of 5. In that case, that polynomial will look like this, a very flat thing going like this here, and then it moves up. So this polynomial has no turning point. It has 1 0, right? And this 0 is very flat here. We say it has 1 0, and we also say its order is 5. Its order is 5. 5 is the order, or sometimes we'll say multiplicity. What I'm trying to say is this function is x to the power of 5. So this function f of x is x to the power of 5. So this 0, there are 5 zeros here. That is what we mean when we say that the 0 has order of 5 or multiplicity of 5. Now that makes a 0 different from x-intercept. X-intercept is also at origin, but x-intercept is just a point where the graph crosses x-axis. 0 tells you how it crosses. Okay, so that's a huge difference. So with that, you probably understand zeros better, and now you'll appreciate it even more. So let's say degree 5 we are considering. So we are always moving from quadrant 3 to quadrant 1, and we are just looking for possibilities of moving. We could also go like this, right? We could have a double 0 here, so it turns, right? And then again it turns, right? And then finally it moves away. Now in this particular case, what we have is we have 3 zeros, right? Let us say this 0 is at minus 2, this 0 is at 0, this 0 is at, let us say, plus 2. Okay, now in this case we have 3 zeros, right? So 0 at minus 2 has order of 2 or multiplicity of 2. You see, 0 at 0 also has order of 2. How about 0 at 2? 0 at 2 has order of 1, right? We normally don't write that. It is assumed if we are not talking about multiplicity or order, then it is 1. Do you see that? So that is also possible, correct? Well, we may have just 1 0 at times for a degree 5 polynomial, where we could have this translated up, right? Let me just change this a bit. If I do plus 1, what happens? We'll have a linear 0. Do you see this like this? So in that case, we have just 1 0, right? So a degree 5 polynomial can have 1 0. The order of 0 could be 1, could be 5, could be 2, right? Could be 3 also. So let me sketch one which has order of 3. So this time what I will do is I'll just sketch it like this and make it 3 order, right? This is kind of 3, and then we need 2. So let's turn like this. How about this? So let us say that this point is minus 1 for us, and this point is 2. So in this case we have 2 zeros. So the 0 at minus 1, we are talking about zeros here, right? So we are talking about zeros. 0 at minus 1 has multiplicity of what? Of 3. And at 2 has multiplicity of 2, right? So it is multiplicity of 2, right? So some students use the term multiplicity, some students will be using the term order. Both are the same thing, right? So that is also possible. You can have a combination like this, right? Or you could also have a combination where we have all linear zeros, correct? So we could have a graph going like this, 1, 2, 3, 4, and 5, correct? So that is the maximum number of zeros a degree 5 polynomial can have, correct? So what we really find is that the number of zeros will be how much? Number of zeros could be 1. They have to have at least 1, 2, 3, 4, or 5 zeros, right? And what you also learn here is that the multiplicity of the zeros could be different, right? So it could be 1, 2, 3, 4, or 5. So let me show you one with multiplicity of 4. So what I will do for that is I'll make another function which is like flatter, right? So just think about it like multiplicity of 1. Do you see that? And then going like this. So this function has a 0 here, which is of multiplicity 4. Do you see that? And this one is 1. They will add up to 5. Anyway, what you understand is, so this is the one where I've shown you multiplicity of 4, right? So when it is 4, it is flatter, more flatter than square. I hope with this you appreciate difference between zeros and x-intercepts and possibilities with number of zeros and types of zeros for any given polynomial. I hope you appreciate it. Thank you and all the best.